In October 2024, the last chunk of Iron Gate Dam was scooped away by an excavator on the Klamath River. The first time water had run freely past that point in 60 years. Crews expected to wait years to see fish come back. They did not wait years. Just over 2 weeks later, biologists spotted a pair of Chinook salmon spawning in a tributary above the old dam site, in water their species had not been able to reach since before the beetles formed. Then it kept happening. Salmon turned up above the next dam site, and the next, swimming into cold mountain streams more than 200 miles from the Pacific, as if they had a map folded somewhere in their bodies. A fall-run Chinook was documented above the former JC. Boyle Dam in Oregon for the first time in more than a century. No one stocked those streams. No one carried the fish upriver in trucks. No one told them where to go. This is the story of a river that scientists had effectively written off, of a fish run that crashed so hard it triggered the largest salmon die-off in the recorded history of the American West, and of how tearing out 4 dams in a single year forced biologists to throw out their own most optimistic models. The speed and scale of the river's recovery has exceeded our expectations and even the most optimistic scientific modeling, said the director of the Yurok Tribal Fisheries Department. To understand why 4 salmon spawning in a creek made headlines around the world, you first have to understand what was wrong with the Klamath. And the problem is not the one most people would guess. From a distance, the dams looked like success. Concrete, water, power. A working river, tamed and useful. The reservoirs behind the dams were postcard blue, ringed by homes and boat ramps. That blue was the lie. Underneath, the river was dying. The dams trapped water in shallow, sun-warmed reservoirs where toxic algae bloomed every summer. They blocked the cold, clean flow that salmon need and replaced it with warm, slow, oxygen-poor water. They sealed off the upper watershed entirely, cutting the fish off from the high, cold streams where they had spawned for thousands of years. The river still moved. It still looked like a river. But the machinery that made it alive had been switched off. The Klamath winds 263 miles from southern Oregon through northern California to the Pacific. It was once the 3rd most abundant salmon-producing river on the entire west coast of the continental United States. 6 federally recognized tribes had depended on its runs for millennia, some of them living along the river for as long as 15,000 years. 4 hydroelectric dams stood in the way: J.C. Boyle, Copco No. 1, Copco No. 2, and Iron Gate. Together they had blocked salmon from roughly 400 miles of historic habitat. Behind those walls sat an entire upper watershed of cold spawning streams, complete and intact and empty, waiting for fish that physically could not reach it. And then came the day that turned grief into a campaign. In late September 2002, in the middle of a drought, federal managers diverted river water to farms upstream. The lower Klamath dropped to roughly 60% of its average flow. The water turned warm and slow, and tens of thousands of adult salmon crowded into it on their way to spawn. The conditions were perfect for a parasite. Within days, the fish began to die. Up to 70,000 dead fish, mostly Chinook salmon, making their way upriver to spawn, washed up along dozens of miles of riverbank, rotting in the sun. People said you could smell the river before you could see it. It was the largest salmon kill in the history of the western United States. 70,000. For the Yurok, the Karuk, the Klamath, and others, that number was not a statistic. It was the river telling them it was about to die. One Yurok woman who saw the rotting fish went to law school specifically to make sure it could never happen again. The fight to remove the dams started in that smell. It would take more than 2 decades. Now here is where the framing matters, because it is the same trap people fell into with the dams in the first place. The dams were not removed to give engineers a tidier river. The salmon were not the side project. The river itself was the patient, and dam removal was identified as the single most effective intervention available, the one thing that could undo the most damage at once. The fish were not the beneficiaries of a nice gesture. They were the mechanism. Restore the salmon's path, and the salmon would do the work of rebuilding the river that no construction crew ever could. The crews tore down concrete. The fish would do the rest, and nobody would have to direct them. What makes a free-flowing Klamath different from a dammed one is not just that water moves. It is a specific set of things that switch back on the moment the walls come down, all at once, each fixing a different broken system. The first is passage. With the dams gone, salmon can swim straight through to 400 miles of habitat that had been sealed off for decades. The fish do not need to be taught the route. The urge to climb to cold headwater streams is written into them. Open the door, and they walk through it. The second is temperature. Without shallow reservoirs baking in the summer sun, the river runs colder and faster again. Cold water holds more oxygen and starves the toxic algae that bloomed every year behind the dams. Lower the temperature, and you remove the thing that was quietly suffocating everything. The third is sediment and gravel. A free river carries gravel downstream and rebuilds the clean beds that salmon need to lay their eggs. Dams trap that gravel and starve the river below them. Let the river move its own bedload again, and it builds its own nurseries. The fourth is the whole food web above the fish. Salmon swim upstream, spawn, and die by the thousands, and their bodies carry ocean nutrients deep inland, feeding insects, birds, bears, and the forest itself. A river full of salmon is not just a river with fish in it. It is a conveyor belt feeding an entire landscape. Restore the run, and you restore the meal that hundreds of other species were missing. All four switch back on together. No agency can schedule that. No budget can buy it. It has to be lived back into existence by a fish doing what a fish does. The results came faster than anyone had dared to model. In late September 2024, an excavator took the first bites out of the cofferdam at Iron Gate, the most downstream dam. Just over 2 weeks later, a crew spotted a pair of salmon spawning in a tributary above it, where the fish had not been able to reach before. News of fish passing the former dam sites arrived the same week the project was completed in early October 2024. Then the numbers started to land. For the first time since Iron Gate Dam was built in 1964, anadromous fish could move upstream of it. A sonar counting station recorded more than 9,600 fish crossing that historic threshold. An estimated 7,700 of them Chinook salmon. Salmon were confirmed spawning above the former Iron Gate site in California for the first time in more than 60 years, and above the former JC. Boyle site in Oregon for the first time in over a century, then the verdict a full year on. In a report a little more than a year after the dams came down, state scientists said salmon were reoccupying just about every corner of their historic habitat. One program manager called the speed at which the fish were repopulating every nook and cranny of suitable habitat both remarkable and thrilling. These were not fish that had been carried up and released. These were wild fish that found the open door on their own within weeks and walked back into country their species had been locked out of for the entire living memory of everyone watching. But the project is not without controversy. And the tension is not really about the salmon. It is about what a torn-down dam represents in a country that spent a century learning to trust concrete. The reservoirs that drained were not empty land to everyone. Homeowners lost their blue lakefront and their boat ramps, replaced overnight by mudflats and stumps. The first year after removal looked ugly. Turbid water heavy with decades of trapped sediment, dead reservoirs collapsing into raw banks, a river that for a while looked less like recovery and more like a wound. Farmers in the upper basin, who had fought the tribes over this same water for decades, watched a major piece of infrastructure simply vanish. And some of the very people who fought hardest for removal were careful about the promise. Tribal members and scientists warned that salmon runs would not come back in a year or even a decade, and some elders said they did not expect to see full recovery in their lifetimes. The ecological argument on the other side is just as plain. The dams were aging, increasingly uneconomic, and the cost of bringing them up to modern fish passage standards was higher than the cost of taking them out. They produced relatively little power. They were strangling one of the great salmon rivers of the continent. Remove them, and the river does the restoration work itself, continuously, for free, on a scale no agency budget could ever fund. Neither side wins cleanly. The reservoirs are gone. The debate over water, farms, and fish in the upper basin continues. And the river quietly keeps rising into country it had forgotten. The removal of 4 dams on the Klamath is the largest dam removal project in United States history, and the largest salmon restoration effort ever attempted. It took more than 20 years and started in the stench of 70,000 dead fish. And in the autumn of 2024, that 2-decade fight ended with an excavator and a pair of salmon in a creek that had been silent for 100 years. The fish spawning above those old dam sites right now will die in the gravel where they hatched, and their bodies will feed insects and birds and the forest, carrying the ocean inland the way salmon have done here for thousands of years. The young that hatch this spring will grow up knowing no dams at all. They will swim down a free river to the sea, and the ones that survive will come back up it, and they will find the high cold streams open and waiting, because no one will ever again be there to stop them. The monitoring program will run for years, tracking the fish as they reclaim mile after mile. By the time it ends, the river will look nothing like the blue, dammed postcard it was. It will look muddier in places, wilder, less controlled, more alive. What happened on the Klamath is not a return to the past. It is an experiment in tearing down the thing humans built and discovering that the river already knew what to do without it. The dams came down, the water ran cold, the gravel moved, the salmon found the door. And a river that had been dying quietly behind 4 walls of concrete started, for the first time in a century, to breathe. But the Klamath is not the only river being set free. In our next video, we look at a dam on the other side of the world, an animal that vanished with it, and what came back when the water finally ran wild again.